Cool.
Yeah, that's it.
So what is Docker? Loads of people always compare it to a virtual machine, but it is different. So in a virtual, does everyone know what a virtual machine is?
Yeah.
Yeah, okay. So usually you've got your hardware, which is the infrastructure at the bottom, and then you've got your hypervisor, which is a very small Linux installation. And then sits on top of that, it's another piece of software that mimics your hardware. Well, that's what the hypervisor does, and then you've got the operating system on there. And everything's isolated. It's got those lines drawn around them. Whereas a Docker, you don't have that hypervisor. It's just an application that sits on your Linux operating system. So on Raspbian for what we'll probably use it for. And then you've got all the applications that just talk to Docker, and it just contains it within that application. And it's all open source as well. This just goes on a bit about the details of how it works. I'm not fully understanding this myself, but I'm sure someone like Paul might understand it all. I'll just leave that up for a few minutes just so we can read through it. So why would we need it? It just makes your life easier. If you're wanting to install something and you've got to install all these applications on a single Linux installation, like on a Raspberry Pi, it just means that you've got to make sure all the libraries and there's no conflicts, and it's just a hassle to do it. Whereas someone's already gone to the hard work for you. They've packaged everything up, all the libraries you need, the right operating system files, and just put it inside a Docker container. It just makes your life easier. So some of the things that you might want: Node-RED, MQTT, Octoprint, Grafana, Influx, and ROS, which is Robot Operating System. And you can have different Linux environments with Docker running on the same Linux operating system. So you can have it, you could have Debian, or you could have another different system on there as well. So a few things to watch out for. So this is the Docker Hub website. So I'm going to go through this anyway. But you've got the architecture. So this has to be the same architecture as your hardware. So you need to select the right one there. For images to download it, you just click on that and it copies to the clipboard, and you just paste that into your command prompt once Docker's been installed, and it'll download that image. This is just a bit more details. So inside the same screen, so inside this screen, if you scroll further down in the web page, you'll get all these details here. They're telling you all the different details for all the different types of hardware or architectures that you can actually extract to pull your Docker container down. And you can have different versions as well. So if you wanted a Docker container from, say, 10 versions ago, you can go on this website and get that particular container. And you can script all this as well, so it just makes it easier. So some of the options to take note of: restart. So if you've got a Docker container and that Docker container only just runs one script, and that script might, I don't know, do something like open the door, then it's going to close down each time. And you've got different restart policies for that. What you might want to do is, if you've got a bug in your software or something's not working quite right, you might want it to automatically restart. So that's when you'd give one of these options. You might always put always in there, so it always restarts. But if you do that, then you might hit some problems and it'll just be continuous restart. So you might be better just doing a on failure and then just restart it, say 10 times or something. And then, you know, taking up processing power and just keeping that in a loop. Cleanup means that if you've got Docker running in there and you clean up every time, so that means you take it back to its default time as it was installed, as the Docker image was installed, then you're not going to be able to look at any log files or diagnose any problems. But it does mean that you can start the application or the Docker container up with the same details every time. And this one's pretty important for all your Raspberry Pi projects. It just means that you can run the container and give it access to your hardware. Otherwise, it hasn't got access to your hardware by default. So you can specify using this device, and you can use, in between that squared brackets there, you can just put I2C, or you can put privilege, and that will give it access to everything. So all your hardware. So a Docker image means that it's going to, it's the image, the core sort of image. The container is an instance of that image. So if you think about object-oriented programming, you can think of the Docker image as the main object, and then an instance of that is the container. Right, so that's the end of the presentations. So I'm just going to go through how to install it. So it's a new version. So what I've got here is I've just got a website that I've used. It's got all the commands that you need to run. Let me just bring a terminal up. So we've got to install these.
Is this running on a Pi?
It is, yeah. Yeah, it's a Raspberry Pi 4. It's got plenty of memory in there as well.
How much memory does Docker take?
It takes hardly anything. That's a good thing about it. So you can have quite a few. I'm going to show you the memory usage of it, but the actual installation isn't that big, and running containers isn't that much. So if you download an image and you want to run, say, 5 scripts, but you want to run, and you've got 5 different scripts, and you want to run each in its own container, yeah. It uses the same image as its base, so it's not having to duplicate that every time, if you see what I mean.
Right.
Now, questions are good because it just means that I'm giving the right information out.
Is Docker good at being able to run older containers in the later versions?
What do you mean by that, Bob?
If you could, create a container, say, a year, 18 months ago.
Yeah.
And you then update Docker, and you want to run that container, would that work? Or?
Yeah. So you can use different versions of containers and still run it. Yeah. I don't think there's any compatibility issues going back to different containers.
Right.
Because it's just a binary from Docker's point of view. Docker's just the engine to run it. So, which one did we run? We ran the installation for Docker. So we installed some updates. We run the installation for Docker, and we just need to give the user privileges. So we're given Pi. We should be given Pi access to Docker here. And we're just doing the key. not got Vim, so I'm just going to use Nano. I hate Vim. So I've not updated it for a long time, so this might take a while actually. So on the Pi, I've got the running off a USB SSD drive. It's far quicker. I just got fed up with the SD cards crashing.
Right. Is the SSD drive faster than a USB memory stick?
Yeah, yeah, way quicker. But it also means that you don't get that crashing bit. That's the bit that annoys me. Because you set everything up, everything's working, and then all of a sudden, you're back to square one. You've got to install all your programs again, and then it just never gets done.
Mm.
While this is running, I'll go to the Docker Hub page and I'll show that. So there's all sorts of different programs. So let's search for Node-RED because that seems to be a popular one. So this is the bit where you can actually click it and you just paste that into your command prompt and that'll install that image or pull that image down. So once you've pulled it down to run it, you can just run this version here. If you're running a Raspberry Pi, you probably want to run the minimal version. And it's as simple as that. So what you're looking for as well is an official version of something, because anyone can upload these packages. So if we just search for Node-RED again, I don't even know whether this one's official that I'm looking at the moment. It doesn't say it's official. No, I'm sure there is an official one. No. Okay. What other programs do we use at the Hackspace? Maybe MQTT. We've got Eclipse. Let's just bring it up on this page. So you can see here at the top right, it says it's the official image. So you know it's going to be safe. If you're downloading it from someone else, they may have put some sort of backdoors in there or some malware in there or something that you don't want. So I always try to stick to the official images. If you click on the image, this is where you can actually click to download it again. And this is where you can select your architecture. So because we're using Raspberry Pis, it's going to be the ARM architecture. And they usually give you some information to how to run it. Let's just check on the progress. That one's finished now. So let's just finish this off. What was the last command we ran? Upgrade. Okay. So now we're just going to start the service. I need to do it with sudo. So if we just do that again and just type in status, we can see that it's active, it's running. Just quit out of that. Telling us to do Docker info, although we don't really need to. It'll just give you the information, how many containers are running, and a load of other stuff as well. It actually tells you the architecture there that you need to run. This bit I'm not going to continue down here, but this just allows you to run multiple Dockers on multiple Pis, and they can all work together and talk to each other. But it's a bit more advanced. So I'll just go through and grab some of the more common Docker packages, and we can get those installed. So just click on the Docker pull. I think we've got to do it with sudo, so let's just do that. You can see it's just downloading all the base images. So if we click on the build option here, it's not actually telling us on there. But this Docker file here is how it's actually building it up. So it's using a Alpine version of Linux, an Alpine Node 4, and it's using version 4. So sometimes they put a colon there, and then they'll put in latest, and that will pull the latest operating system. But sometimes you might not want the latest, because you might be building this over a period of, I don't know, 3 years, and it might not work on the latest version of Linux. So you want the older version to run just this application. And that's what he's doing here. He's just downloading version 4, whatever that is. And this is just installing everything that he needs in there. And it's exposing a network port here. So because this is running as a web server, the Docker container needs to have a port open for the operating system to talk to it. So it's saying the Docker container is going to be listening on 1880. And then when you type in the IP address of the host machine, or the Raspberry Pi's machine, it's going to redirect it to that Docker container. You only can have one container listening on that same port.
Different containers can be listening on different ports.
Yeah, so we could have, say, 100 different Node-RED Docker containers, and they'll all be listening on different ports, and you could communicate with each one of them if you just type in the relevant port. Let's see the next one. I'll get that up and ready. Do a smaller one. MQTT. All right, so that's finished. So if I type in Docker container, in fact, no, let's do Docker image ls. So what I'm doing there is looking at running the Docker command. Then I'm saying get the images and then list all the images. So you can see we've got a Node-RED there. If we do Docker container ls, there's nothing there at the moment. So what we need to do is we need to change that image into a container. So we need to run this command here. So that's saying Docker run map port 1883 on the host or on the Raspbian to this Docker container 1883, and also same for this port number here. This is network ports. And then it's saying these are the configuration file locations. And then that's the name it's going to give the Docker container. So that'll appear in this column here. Oops, if I run it as sudo.
You know, rather than typing sudo every time, I prefer to switch to a super user, then you don't need to do that.
Yeah, it's probably better, yeah. For some reason that hasn't worked. Let's try.
It's only a sword mode, right? Hello?
What's the difference here? See what's happened. Docker container. Just remember that. No, that's not a run. Let's move on to the next one. Mosquito is a small application, so it won't take long to install it. So if we do Docker image ls, listing all the images, and then we should be able to run this. I think if we get rid of the IT, it'll just run it without actually running it interactively. No, it doesn't want to drop it. So let's just bring another SSH command, just leave that running. Install the next one. Let's get on latest, and then we'll just run this command after. Not sure why the Node-RED isn't working, but I've got Node-RED running on the other Raspberry Pi that I've got set up. So this is all working, and this is using Node-RED for the connectors, MQTT, all running on one Pi. Then it's picking up from the MQTT, and then it's changing the number that it's getting from here, which is converted to text at some point to back to a number, and then we're sticking it back in a database, and we can query on that database. Let's go back to this one. Octoprint. So that's not going to work as is. We haven't got a Octoprint installed. Sorry, a device. container. So it says it's running, but I'm just trying to work out whether it is. No, it's not running. So it's actually giving me the container ID here. So what I can do is I can remove that container. So I can type in sudo docker rm and then the container ID. Container. All right, and that should be working. So if we just try, so the IP of this Pi that I'm connecting to is 192. And then do 5000 because that's the port of exposed up here. So this is what address it should be running on. And we've got Octopi. No idea how to use this, but I know a lot of people use this to do the printing. But you'll just go through all the configuration for that and then that would be working.
Yeah, I use it a lot because I have it on both my printers.
So what do you use out with this?
Well, basically, it acts as an interface for the printer itself. So I tethered print rather than print from SD.
Right, okay.
So,
wasn't he having some problems with that though? Wasn't he?
Yeah, I've never had a real problem with it.
Right, okay. Can you see any advantages of running this in a Docker container?
In theory, you could run two, if you have two Docker containers, you could run two simultaneously on one Pi to run two printers at the same time.
Yeah, yeah. So just to reduce the amount of Pis you need to...
Yeah, but I maintain it's a point of failure. So I use separate Pis for each printer.
Yeah, yeah. You can with Docker as well, with another sort of layer on top of it, you can use something called Kubernetes.
All right.
And that means that if one of the Pi dies, then it automatically just puts it onto the other Pi.
Yeah, so I've heard.
Yeah.
But if the Pi is going to fail, the printer's going to go with it at the moment. So it's like...
Yeah, it's not...
Or vice versa. So
I'm thinking more for like the Hackspace stuff. Do you know if you've got anything running, like opening doors, like anything like that? It might be useful.
It could potentially be.
So what else have I got to install? There is Grafana. I can run through quite a few of these installations. I just wanted to show you how easy it is to actually get it up. So sudo. Has anyone seen any? What would people prefer to do for the next, I don't know, 10, 20 minutes or whatever? Would you rather see some Visual Studio Code and how it links into it, or would you rather...
That'd be quite cool.
Look at some Node-RED stuff? I'll do the Visual Studio Code because that's quite interesting. It's Has anyone got any questions on what we've done so far? Any misunderstandings or anything like that?
No.
No. Cool. All right. So what we can do, so this is a Visual Studio Code. It's an editor, so you can start writing code in Python, C. I've also got this platform IO installed as well. So you can actually write to Arduinos, and it's got all the packages managers included in it. So you can write to not just Arduino, but other boards as well using platform IO.
Yeah, I've recently started using platform IO to write firmware for printers.
Yeah, I just find it so much easier because you can have all the information and configuration files, so you don't have to...
Yeah, it's not that for me. Yeah, yes, all the configuration files together in one place is very useful, but it's the compile time I love the most about it. Because it's like the Arduino environment was taking like 20 minutes to compile and then another couple of minutes to upload. And it's like, I was running it on platform IO and it's 30 seconds to compile and 40 seconds to upload.
Yeah, it's far quicker.
enormously so.
The benefit of this as well is that if you've got an Arduino that's in reach of a Pi or another Linux system, is you can connect to that Pi through Visual Studio Code, and you can write to the Arduino using Platform IO just through the plugins in Visual Studio Code.
Sounds interesting.
Yeah. So what I'm going to do is connect to the remote host, and I'm going to have to remember what the IP address is. Can anyone remember for me?
Not off the top of my head.
No, here we go.
In the browser.
There we are. So all we do is type in pi at, and then the pi's for the username, and then at, and then the IP address. And then we just enter that. It'll probably want to open a folder. We'll say it's a Linux system. First time you connect to a machine, it takes a bit longer because it has to install some libraries or some configuration files. All right, so then we've got to tell it what we want to do. We want to open a folder to start doing some development. For some reason, it doesn't let you create files from that. So we have to create it from the command prompt, sorry, a folder. So mkdir, let's call it hello world. Let's just copy that. Paste that in there.
Martin here. Which machine is the Visual Studio Code running on?
The Visual Studio Code is running on my PC, so it's a Windows 10 PC.
Yeah.
There is, however, a Linux version.
Yep.
Which I was utterly amazed about, considering it's made by Microsoft.
Yeah, well, Microsoft's doing everything at the moment. I don't really care. As long as I think the idea behind this sort of Visual Studio Code is to sort of get you hooked into their cloud system, but you don't have to use their cloud system. Hello world. This is just a Python, so import. Probably don't need to do that, do we? We just need to print hello world. And then you can actually run this on the client. So you can install the Python. It's already installed on mine because it says it's just installed on my version, but you also can install on the remote system by clicking that, and that's installing it now. So what I'll be able to do is just run that on the Pi from Visual Studio Code. But what I'll do after this, just show you a little script and then show you how to change it into a Docker container. So we could just have this in a loop. So just going to loop through, and let's just do a time.sleep. So I need to import time. So it's saying that I've got to reload.
So you might want to put a counter of some sort in there, otherwise you won't be able to tell if it's running or not after a while.
Yeah, I can put the time in or something, can't I? So print counter. Right, can you see at the bottom right here, you've got to select the interpreter. So if you click that, and it should pop up with a menu up here. That's it. Select Python version 3. We'll install the linter. That's fine. So counter equals 1. Then if we just do counter equals counter plus 1. In fact, rather than having that on a separate line, let's just stick it in there.
Because your code needs to be in that's print the word counter, isn't it? Not the.
Thanks. Cheers, Bob. Okay, that should work now. We should get a little prompt at the moment. Yeah. So that's working, and that's all running on the Pi at the moment. So how come it didn't sleep? Ah, that's better. So if you press Control Shift and I think it's P, and then if you type in we should have Docker. So what I need to do is I need to install a Docker client on the remote machine. So there's with Visual Studio Code, you've got loads of plugins.
What version of Visual Studio have you got there, Alex?
It's Visual Studio Code.
All right.
And it is version 1.45. It's one of the later ones. Every time you start it up, it always asks you to install the latest one. Pretty much do.
This is the ID of Visual Studio.
Mm-hmm.
So do Control Shift and P, right, and Docker here. I think it's add. So if you do add Docker files to this workspace, and then we just say we want a standard Python. For some reason, it's not got it. I'm going to go for Flask. We don't want the compose files. Compose is just an addition for Docker. And then we'll look for hello_world.py. We'll say 5,000, but I've not really got anything listed on 5,000, so it doesn't really make a difference. So what we've got is our hello world we originally got, and Microsoft's created a few other files for us. So these are used to install or build the Docker container. So it's building a Python list from this version of Linux, so 3.8 Slim Buster. Sometimes with the Slim versions, when you're running Python, it can cause problems, and it's probably actually better not to do that. So I'm going to change it. So we can actually probably change it here. I think in Visual Studio Code, if you start typing Buster, it should bring them up. Nope. Let's just search for it, yeah. Or if we search for Python first, this is the official image for Python. Then we go over to the tags page. And it's got all these different versions. So Alpine is a very slimline version of Linux, but Python tends not to run well on it. So I'm looking for a Buster version. Let's see whether I can. Right, you can see we've got Slim Buster here. Slim Buster, Slim Buster, Slim Buster. I don't want any of those. Right, okay, here we go. We've got the full version of Buster there. So if we copy that and then paste it into this, in fact, let's paste it on the line below. All we need is that bit there. So that means it's going to build this Docker container on this version of Linux. It's going to expose port 5000, but we don't really need that. Not sure what these are for. This is something specific to VS Code. So what it's going to do is it's going to add any libraries we want. So if we wanted to add a library, we could just add it here. So for example, if we go to PyPy, and let's, should be a search somewhere around here. Download maybe. MQTT Python. And this is what we can install. So what a lot of people tend to do with Docker is rather than saying download the latest, which is that's what that's doing, is you can go to release history and you can click on a particular version and then you can just copy that. You can see it's got the 1.50 at the end. Close that, paste that in there, save it. It means when it gets to this line here, it's going to look in that requirements and it's going to install that version of MQTT. This means it's going to copy everything in this folder here into the app folder, and it's going to make the app folder the working directory within the Docker container. This is just adding the appropriate users, and this is running the application. So not sure what this bind does. All that does, this is saying on this open up port 5000, and this is the script that we're running. I think that should be a full stop. Let's try it as it is, see whether it errors. So I think if we just press play here. No, that's not doing it in Docker. So if we go to debug, let's play it from here. So, all right, so this is building the Docker container up now. So you can see all the commands that were in this file are now being run. So the first one is pulling this Docker container. This Python 3.7 Buster. Has anyone got any questions from you?
No.
What you can also do, because you've got the Docker container, you can see what Docker containers are running at the moment. So that's just that button there on the left-hand side. You can see that these are containers currently running. This one's been created, but it's stopped. So you can actually remove that, the one that's stopped, and just click remove and remove it. These are the images that have been retrieved from the Docker hub. You can have a network for all your Docker so they can all talk to each other or not talk to each other. Depends how you want to set it up. Registers means that you can connect to the Docker hub and retrieve more images, but it also means you can upload your own images to the Docker Hub. I'm not sure how much space you're allowed to have on Docker Hub. You might have to pay more money to store more images on there. But you can see now this is carrying on through. It's getting all the pip installations. We're building the Payo MQTT that we did earlier. So you can see it's running Hello World now. So that's all running in a Docker container. Which machine am I on here?
On the Pi.
Say again?
It's running on the Pi.
It's running on the Pi, yeah, within a Docker container. So if I do Docker, let's do a sudo Docker container ls, you can see it's got the hello world there. And it's been up for 35 seconds. So what you can also do, if you look at htop, you can see it just runs as a normal process. So you can see it there. But it doesn't take up much RAM at all. It uses very little. Because I'm connected in through VS Code, that's probably taking up the most amount of RAM. But there's very little that runs when you run a Docker container. It's surprising how little anyway. But you can have as many of those as you want. So if you wanted to create a bigger Python sort of system, you just add more here. You can change the Docker to be whatever. You can run a bigger version of Linux or a different version of Linux. Open more ports. You could have a, because we've got Flask installed, we could make this into a web server. Let's see whether we can do that, because that might be an interesting thing to look at. Just look and see whether I can pin some code from someone. All right, looks like this could do it. I'm just going to comment all that out. It's going to return a hello world. To Flask, let's see whether that works. So let's stop that. Restart. All right, let's just play. Let's play again, see whether that works. All right, so you didn't see that, but it started up and it's opened up a web browser. You can see the hello world. So that's giving me an address now. So you could put anything there. You could put hello Sheffield Hackspace. And you've got your own little web server in a Docker container. Seems to run through these a bit quicker as well now. So that's opened up. Has anyone got any questions or anything that they want to see?
No, I think need to get down to playing with it to you make it look so simple.
Yeah, well, it's not that difficult. It's some concepts you got to get your head around, but it's not that difficult when you get into it.
Alex, it's Rich here. Thanks very much for this. This is a really good overview. I just wondered if you had anything on Docker Compose. So, you know, bringing in a few Docker containers and making them work together, like a web server and a database or whatever.
I've got nothing to show you. Do you mean how it works, or do you mean, because we can create a Docker Compose from this just using the tools in Visual Studio. So if we do a Docker add, and then if we choose Python general, it says, do you want to include Docker Compose files? So we can just say yes to that. So it's hello_world.py. So we'll overwrite the existing files. Yeah. So if we look in the files here, we've got the Docker Compose file. So Docker Compose is just Docker file is a simplified version of Docker Compose. So this can only run one Docker container, this Docker file, whereas Docker Compose can open up multiple Docker containers in one file. So what you generally happen in a company or someone who's designing something a bit bigger is you'd have multiple Docker containers, and you sort of shrink or break down the application into smaller pieces, and then you'd have each piece as a service. So this is one service, the Hello World, and then you might have another service that does something else that talks to the Hello World. Probably not the best explanation, but it's just a way to break down the complexity of building bigger applications. Did you have a particular application in mind for Docker Compose, or that you might want to share so other people understand?
Yeah, okay, thanks, Alex. So I, a couple of days ago, I ran a thing called OwnCloud, which is kind of like an open source host it yourself Dropbox. I went through the instructions, they were pretty comprehensive, and actually managed to get Docker Compose to run a, what was it? It was like a MariaDB container.
Yeah.
Along with a Redis or something. I think it's an authentication sort of application.
Yeah, I think Hackspace, is it?
Yeah, probably. Yeah. But I guess that's it. Like, I didn't really understand what I was doing. I followed the instructions. It worked. I've got OwnCloud running on a Raspberry Pi 2, you know, and it kind of works. But I kind of understand YAML, this sort of markup language, but I didn't really understand the details and exactly how it communicated with each other and whatever. So I guess if for anyone else on the call, you know, if you wanted to just have a go and know that something will definitely work, I would try it out OwnCloud and then probably work out what you've just done after you've done it, because that's what I'll do after this, I think.
Yeah, well, that's pretty much what I've done when I've been doing all this, learning all this. Start with something basic. That's why I started with Docker files. Docker Compose is probably the next one up, where you want to have multiple applications talking to each other. And then you might later go on to Kubernetes to sort of get them all working together and manage them. But it might be too much. But a lot of people, I guess, just want to sort of a quicker way to get a application up, which is what Docker's useful for a hacker or a maker. Or even if you're just doing something at home, like you say, like, you know, getting OwnCloud up and working, because it can be a bit of a nightmare.
Yeah, I normally sort of twist myself in knots, and then the last thing you want to do is have to completely reinstall your entire system, and then you accidentally overwrite other projects that you're working on. So Docker just is basically disposable, isn't it?
That's it. Yeah. Just chuck it away once you finish with it. It reminds me, the other thing you've got to work out with or decide with Docker is that if you're running a database or something, you might not want to run the database in the container. You might want to run that on your file system or on a NAS device. And then it just means that if you do want to throw your container away, you can throw that away anytime and just restart it, say with the latest version. And it just means that your database will still be there in its entirety.
Oh, Alex, actually on that subject, would you mind going through volumes? I may have missed it because I was late on the call, but kind of linking volumes up.
I haven't actually gone through it. The only thing I've got with that is work stuff, and I don't really want to show anything that I've done with work. Let's have a quick Google. Now, I can't find anything to hand for that. But essentially what you can do with the volumes that he's talking about is you can just have that, so you can have more than one Docker container share a volume, or you can have that shared on a NAS somewhere. Anything else?
No, thank you very much, Alex. And I think it's a case of finding some time to play with it now.
Yeah. Well, it's all recorded anyway, so if anyone needs to go back or anything, you can do that. What I will do is I'll share a Docker video that I found useful. I'll send it through on the email. So it's a recent, it's how to use this Visual Studio Code for Docker.
Yeah.
You can literally just go through what I've gone through on this sort of side of it, and it'll explain it in a different way.
Excellent.
Well,
Thank you very much for your...
I came in a bit late, unfortunately. I just got in, so I've missed the first 50 minutes at least. 7:50 I came in, so I missed the best bit, I think. So I'll wait for the recording then.
Yeah. I'll stick it on the blog for the Hackspace, and then people know we're doing stuff.
The problem I have is Visual Studio. I've had that many unhappy days with it.
Yeah.
It's given me a really bad feeling whenever I look at it.
Yeah.
Because you don't know anything, is it? They've made it do a lot of things and really well, but the basics they've just mucked around with, and it's just difficult to do anything simple. You've really got to understand it, and there's hardly any videos around show you how to work Visual Studio. That's what I'm interested in.
Yeah, well, I can show you around Visual Studio if you want.
But like with Arduino projects, you don't open a project, you open a folder. I found out last night. But things just are so unfamiliar. Rather than improve on what we know, they've just done it a different way.
Well, I think you're talking about Platform IO, aren't you?
Yes.
Yeah. So Platform IO is a plugin within Visual Studio Code. So it's not Visual Studio Code itself.
I get the two confused.
Yeah, so all that Visual Studio Code is doing is the syntax highlighting, and all the clever bits being done by Platform IO.
So Visual Studio is just the editor then? Doesn't
essentially, yeah. Yeah. And then Platform
So what
IO.
have you got running? Yeah, what have you got running here?
So this is just Visual Studio Code.
Yeah.
This is connecting to Docker. So I'm just running Visual Studio Code, and then it's just running the Python application directly on the remote Pi.
Oh,
But what I'm saying is that you're because you're doing Arduino, you're running the platform I/O, because Visual Studio doesn't know how to talk to the Arduino. It's the platform I/O that knows how to do that bit. So what platform I/O is doing, what their business model is they've created a piece of software that will work on with any IDE, and it just happens that you're using Visual Studio Code as the IDE or the code editor.
yeah.
So it's probably more of a lesson on platform I/O that you want than it is on Visual Studio Code.
So on this one, is it a Python program you're running? Is it Pi?
Yeah.
So this is the editor. How do you run Pi from here?
So if I wanted to run this locally, then I would just click this button up here.
So what's in the background? What's behind that button? Have you loaded Pi in? Python? Have you got a Python add-in or something?
Yeah, so Python this is just a code editor.
Yeah.
And by clicking that button at the top is the same as typing Python 3 and then whatever the actual name is, so hello world.
Right, right. Oh, I see, that's the terminal. Right, oh, I see, yeah.
Yeah, so Python's already installed on Raspberry Pi by default.
I've got that then, yeah. Yes, I've got to familiarise myself with that. I'm still using the old Arduino IDE and, you know, it's and Notepad++, which is very good, but there's two things running and
yeah,
just getting your head around the actual Visual Studio.
Yeah, well, the Visual Studio is quite easy. So all you've got at the top left is you've got your Explorer. So this is the way you're looking at all the files.
Yeah.
I don't think I've ever used this, but this, I think you can just search for items within the file and then replace it. Or just search for them. This one's quite useful if you're using Git. So like GitHub or GitLab.
Right.
You might have your own private one or something like that as well. But what you can do is you can upload your code to GitHub and keep it in sync so you've got all that source control. This one here allows you to run the Python file in a debug mode, so you can actually put stops and you can look at what the code is when at those stop points. And then you can use your F11 or F12 keys and you can just do line by line.
Yeah.
I think you can on the platform I/O if you're doing that on the ESP32 as well. You can just step through your code.
Really?
I've seen Graham do it, yeah.
Oh, that's ESP32 though, isn't it? It's not the ESP8266, is it?
That's right, yeah. So this Remote Explorer, I think this is a plugin. So this is an extra thing you install on top of Visual Studio Code, and you can connect into extra devices. So this just has SSH machines, so just machines that exist on the network.
Oh.
This one is where you can install extensions. So on here, this is where you'd have the platform I/O.
Yeah, I've seen that, yeah.
Yeah, so I've already got this installed. So I can install it on the remote client I'm remoted into at the moment. So I'm remoted into a Raspberry Pi. What else is that's useful? And then the Docker, we've already been through. You can probably catch up in a video for all the Docker stuff. But that's what I've been demoing today.
You make it look reasonably straightforward.
It's once you get used to it, you're using it a fair bit, it's quite easy.
How does Visual Studio Code connect to the Pi? Is it through SSH?
Yeah.
No, when it does a remote install.
Yep. So Yeah, so your SSH into it installs so it runs a little script file. You can't actually see it, but it does run a script file on the Pi, and it installs some plugins or some libraries, and then you can connect to it and communicate with it. So essentially, it's running a client, running a server on the Raspberry Pi, and the Visual Studio is talking to that.
Right.
But I find
So,
it.
Alex, yep.
Yeah, go on.
Sorry, Alex. I was going to say, so when you're running Docker and you're pulling an image, then because you're doing it technically from the Pi, then it will automatically detect that you need an ARM HF or whatever, architecture image, right?
That's right. Yeah.
Yeah. Okay. So if you were doing it on your computer, then it would do an x86, x68, or whatever it is, x86. Yeah.
That's it. Yeah. Yep. You got it.
Okay. Yep. Okay. Thanks.
That's a big got you, because when I first started using it, I was like, why is the Docker container working? I didn't realize there were different architectures. Yeah, so you've got to make sure you've got the right one, but it will do it automatically. But sometimes it'll give an error and say it's not got one for your operating system.
Mm-hmm. And could you do some of the work on your, say, faster machine, like pulling an image or building a container or building an image? I forget the nomenclature, but doing that on your bigger PC and then shipping it over to the Pi, or does it just not work like that? You can't do any work.
Yeah,
because cross-compiling.
The way to think about it.
Yeah.
The way to think about it is all you're doing is building a list of scripts up. So when you're saying from whatever machine, it doesn't matter whether it's a PC you're running on or a Pi. You're just building up the scripts. As long as there's an architecture available for that machine there, for your computer, you can just run it. And then if you run it on any other machine, doesn't matter what architecture it's running on, it'll run through the same script and get you to the same place.
Yeah. But I guess if you were doing it on a standard PC, it would take the x86 image and it would only be able to run that on an x86 machine. But if you say preface that with, say, from ARM/Ubuntu or something, or Debian, then it would pull the the ARM related image of Ubuntu, but then as long as you didn't try and run it on your home PC, could you somehow transport that off to the Pi to then to run in that architecture?
You can copy containers. I think you can export them and copy them across in USB or over the network.
Yeah.
But me, the idea is you just build the script up and then run it wherever.
Okay. Yeah. I'm just wondering whether it would save any time, given that the Pi is fairly underpowered compared with your standard PC.
Yeah, I don't see the need to do that, but I'm guessing there might be some circumstances where you can do that. Yeah.
Yeah. Okay. Thanks.
Yeah, but I see what you're asking now. Can you download a different architecture to what you've got on your PC?
Yeah, and effectively, I think someone else chipped in and said cross-compiling, and I guess that's kind of what I'm asking as well.
Right. Okay. I don't know if you can do that. I don't know.
Okay. Thanks.
Alex, it's Martin. Why? What would be the benefit of using Docker to run Python rather than a virtual environment on the Pi?
So a virtual environment, you don't have if you wanted to run, so say if you got Raspbian,
yeah,
and you can run as many virtual environments as you want, but if you wanted to run that on a different operating system and you wanted to sort of contain it so it wasn't affecting any other programs, because there might not just be a Python interpreter, you might have other things that you want to separate as well. I can't think of any examples at the moment, but there will be cases. And I find that containers are easier to run than Python scripts. So I hate the service model within Python, whereas the Docker containers, and you can manage them a lot better.
Right.
Does that make sense, or are you looking for?
Well, no, I can't. I can't see the advantage on a Raspberry Pi, on perhaps on a larger system where they've got more complex development needs, possibly.
Yeah, okay. There are benefits.
I think what Martin is trying to say is if all you've got is a system and you want to run a script on,
Yeah.
no point in getting a Docker, you know.
If you've just got one small script, then yeah, you probably don't need it, but you might find that as you start building up and get more complex, you probably will do.
Or if you've got lots of things running on your system and you want to isolate certain programs or processes, then Docker is ideal.
How easy is it to copy environments over from one machine to another? Or to get an exact same, if you've got multiple, if you've got multiple machines that you need to run it on, and it's the same script, and each machine's slightly different, maybe different older versions of Raspbian.
Yeah.
With Container, you can make sure that everything is same.
One option, Alex, is if you're wanting to scale stuff, which is particularly like for web servers. So if you're running like a Pi farm as a set of web servers where you've got like a load balancer fronting the request, which then hands it off to a number of, say, like 5 different Pis that then serve the web requests, you can basically use the same Docker container across all of them, and therefore it keeps them all in sync with what content there is, and it helps manage that easier. It's what EMF do.
Yeah, yeah. And if you're wanting to get a bit more advanced, you can start looking into Kubernetes, which manage the containers. And if you've got one Pi that dies, the Kubernetes will realize that the Pi has died and it'll open up that same container on a different Pi. So you can there's different levels to using it, but this is sort of I've kind of aimed it at a sort of maker level, how you can use it in your projects.
Well, the other thing that we're looking at it for work, and this would be applicable for makers and hackers as well, is that if you've got a script that definitely works right now, using the current versions of all the libraries and packages that dependencies on it, then if you start upgrading in the future and something breaks, then you might end up in a kind of dependency hell where you've upgraded something or you've been forced to upgrade something, and now suddenly your code doesn't work. So if you just containerize it, then you definitely know it's going to work.
So just going back to what Martin said, just make it clear for people. So if you add that because he was talking about using environments for Python, you can have that, but can you for other coding languages?
With R, I think there's a thing called renv.
Yeah.
I haven't used it, and then there's another thing called packrat, but I'm not entirely sure how dependable they are. Whereas I guess at least with a Docker container, you definitely know it's self-contained and it works. Yeah,
definitely. Yeah, I'm with you on that. Yeah, data science people use it a lot in terms of getting all their packages all the same and making sure that they can recreate them and putting extra containers on there to take on extra resources that might be needed at a particular point in time. A lot of people use these containers not just on Pis but in the cloud, so you can just fire up a script on Azure or in Google Cloud. You can fire up 100 or 50 containers, and you just pay an extra bill for that period of time. Anything else?
Going back to that question about the cross-compiling sort of thing and doing different architectures, Docker's not really that type of thing, because Docker's not actually compiling anything. What you're doing is you're downloading pre-compiled binaries of like OS files for the specific architecture. So there's no benefit downloading it on an x86 PC to then put on an ARM PC, because all you're doing is moving files around. You might as well just download it direct to the Pi.
Yeah, good point. I guess you might be doing some, if you're using C++, you might be doing some compiling at the time as well, though.
Only if part of your actual Docker project is actually to compile software, but pulling Docker images generally is pre-compiled applications, like pulling down, say, Mosquito or pulling down a MariaDB. It's all pre-compiled.
Yeah, yeah.
I guess the real work happens if you have to, run make and compile your own software. But then you get into the problem that it uses the environment you're in to work out how to compile it. So is there a thing called like QEMU or something which allows you to emulate another architecture? But that all sounds really complicated and beyond me. So yeah,
that's what I use to run all my virtual images.
Okay.
You can use it in two modes. There's like user mode, which is what you just described, where it lets you run other native applications in their architecture on your system, or you can just use it as like a VM image. So run just virtual instances.
Okay.
Because in theory, you can use that to cross-compile, or well, it's not really cross-compiling. Doing stuff for a Pi under ARM on an x86, I've not done it, it's tricky.
Yeah, because I've just noticed that there's a lack of R-related images for ARM. So I've had a quick go at trying to build an image myself using like Debian as a base image, and then doing a sudo apt, install rbase. But then, I think things are just going to get a bit fiddly, in terms of I probably need to do what you've done in like that Python pip install from a requirements file.
Yeah.
I'll need to do the equivalent in R. Because there's a Rocker project which will allow you to download various different images with Shiny servers and other things, but not for ARM architecture, so it won't run on Raspberry Pi.
Is there an Anaconda image you can grab?
Oh, yeah, okay. Does that have? Oh, that has RStudio inside, doesn't it? Yeah. I don't know whether there's an Anaconda for Raspberry Pi.
Yeah, I don't know. Shall I have a quick look? Docker. So this doesn't look like a package. It says it's a container though. Just doesn't come up in the usual way. Try signing in. Don't know what I'm signing up to here, but yeah. So it's got it there. I don't know what architectures. It's not giving me the usual options. Because usually you can click on tags and see what it's got. But it is taking us over to the Anaconda page, links to it. Shall I try running it, see what happens?
Oh, I mean, they are disposable, aren't they? So
There are Dockers for Miniconda as compared to Anaconda.
Right, it's not letting me access that resource for some reason, probably because it's behind a sort of firewall. But yeah, I don't know. You'd have to probably just have a look, and yeah, like James says, try the Miniconda, because it'll probably be smaller just to fit on the Pi. What kind of stuff are you doing? Are you just practicing the Docker, or are you actually wanting to get some R written?
I guess it's partly practice with Docker using something I know, but then also I guess where other people are more comfortable with Python and Flask, I'm a lot more confident with R and using Shiny as a web server.
Right. Okay. Yeah.
Instead. Yep. Also, I'm sure Python's probably done this years ago, but R has a thing called Plumber, which allows you to create your own APIs as well, which would be pretty useful in a Docker container.
The way that Python do it is they do it through Flask, so they just which is just a web server.
Okay.
On mine, the Anaconda Docker file comes up as x86 only.
Oh, okay. Yep. Makes sense.
Or specifically 64-bit, but there is not an ARM version.
Mm-hmm.
Anyone got any more comments or anything to add?
When I was tinkering with Docker, I've got Open Media Vault installed, and there's a Docker add-in for that, and that just hides all of the complexities of Docker, and you just tell it what image you want, and it downloads it. So I found that was a nice, simple way to get started.
Yeah, no, that's good. I think there's quite a few things out there. I guess it's just choosing something that's that you want to play with. Are you still using that, or did you just set it up for?
In the end, I set it up and then I put a Plex image on it, so I use it to access my media.
Oh, okay, cool. Was it easy to do once you've installed it? So is it just a matter of running the Docker pull and whatever, and then?
Yeah, well, you don't even have to do that. It does it all. It's all driven off menus on Open Media Vault. And the other thing I found, which was quite useful, is there's an image called Watchtower, which you load up in Docker, and that monitors all of your images, and if it finds a new version's been released, it updates it for you automatically.
I'm not sure if that's a good thing or not.
Yeah.
You get home and nothing works, can't get in the door or anything, because it's all controlled by Docker.
It's like starting or coming into the office and finding that bloody Windows updated itself and everything stopped working. Right, guys, thank you very much, Alex. I'm going to call it a day.
See you later, Bob. And
much appreciated, all your time and hard effort.
Yeah, no worries. Hope it's helped you.
Yeah. Take care now.
See you, Bob.
Catch you later.
Is that like a statistics kind of program? I'm sure I've heard of it before.
Yeah.
Yeah, I thought so.
Yeah, it is. It's I guess where Python is an object-oriented programming language, R is very functional. So basically everything is run as a function.
Okay.
What I want to know though is what happened to E through S. It was C and D.
Yeah.
Now it's R.
Well, I know about S. So S was the statistical language that predated R.
Oh, okay.
And then I think R was written. Well, R was named as a tongue-in-cheek homage to S.
Right.
By two people whose first names or last names began with R, and they were part of Auckland University.
What is it you use it for mainly? Is it to do stats or machine learning or something?
Yeah, both of those things. Yeah, and I learned it for work, but it's pretty useful actually. It can do. I think that it could do basically everything that Python can do. There's some things it struggles with, like web scraping and some other things that, and maybe integration and stuff like, it certainly won't run on microcontrollers. There's no Circuit Python equivalent. But what it can do really well is munge data. So you can transform data, you know, columns to rows, rows to columns, summarizing, grouping, filtering, you know, that kind of thing. It's really easy. That's probably its big strength.
Yeah, I quite enjoy doing the data science stuff. It's once you get into it, it gets interesting.
Yeah. And there's like statistical functions that would be very difficult to replicate in other programming languages, and also things like machine learning and even like neural networks and stuff. You know, you can do fairly straightforwardly in R.
Mm. What sort of applications do you use it for?
So I mean, for work, we use it for kind of descriptive analytics. So you know what has happened and why. Predictive. So what's going to happen, and then I guess what's the other one? Prescriptive. Like what should you do, as well. And I've used that in like the rail sector, electricity, like networks and energy, and you know that kind of thing. So kind of asset deterioration and failure modeling, natural language processing and stuff.
On the basis we appear to be finished with Docker, shall I stop the recording?
Yeah.
Yeah.